Welcome to the Explainer. Today, we're diving into something really cool, a new method that's designed to turn AI from just a tool into a genuine partner in discovery. It's all about giving AI a mind that can, actually think about its own thinking.
So let's just start with this question. What if we could build an AI that doesn't just spit out a final answer, but actually questions its own process, and can even tell you when it's just not sure?
You know how it is right now. A lot of the most powerful AIs are basically black boxes. You ask a question, an answer comes out, but how it got there is a total mystery. Well, a new approach called CLIO is designed to flip that script, turning AI into a colleague that's transparent, adaptable, and actually shows its work.
And that brings us right to the heart of the matter with a lot of today's models, this black box problem. This isn't just an academic curiosity, right? It's a massive roadblock, especially in really high-stakes fields like scientific research, where the why behind an answer is just as critical as the what.
Think about it. For a scientist, or really any expert, using an AI that has a fixed, rigid way of thinking is like having this brilliant assistant that you can't actually talk to. You can't guide them, you can't tell them if they're starting from a bad assumption, you just have to take whatever they give you. And that's exactly the gap CLIO wants to fill.
So the dream really is to have an AI that can change its strategy on the fly and show you its work, just like a great human collaborator would. And that's precisely what this new system, CLIO, is built to do.
Okay, so let's break this down. CLIO stands for Cognitive Loop via In-Situ Optimization. Big words, I know, but the idea is actually pretty intuitive. It's basically a framework you can give to a standard large language model that lets it think about its own thinking, check how confident it is, and switch up its strategy all in real time while it's tackling a problem.
And this is such a crucial shift. We go from being just passive recipients of an AI's answer to becoming active partners in the process. We can actually guide it and trust it because we can see what it's doing and even influence it.
So how in the world does CLIO actually pull off this kind of self-aware thinking? Let's take a little peek inside its cognitive process.
So first off, instead of just picking one path and sticking to it, CLIO starts by thinking wide. It basically brainstorms, coming up with a bunch of different strategies to solve a problem all at once. It's kind of like casting a really wide net to see what it can catch.
After that initial brainstorm, it looks at all those paths and dives deep into the one that seems most promising. And here's a really key detail. It does this deep dive on what's called a clean slate, a totally separate workspace. This is so important because it stops the deep exploration from getting messy or biased by all the other ideas it was just thinking about.
And this really shows us its core cognitive loop. It brainstorms wide, it dives deep, it isolates its thinking process, and then, and this is the critical part, it takes a moment to reflect on its own confidence level. This loop is what allows it to adjust, to adapt, and even to say, maybe this isn't working, and backtrack.
This ability to self-correct in real time is that in-situ optimization we mentioned. And honestly, it's the secret sauce here. The model doesn't need to be taken offline for weeks and retrained on massive amounts of data just to learn a new way of thinking. It actually learns and adapts as it goes.
Okay, so this all sounds very clever and self-aware, but does it actually work? Well, the researchers put CLIO through its paces on a set of notoriously tough science exam questions. And the results, they were pretty dramatic.
So, get this. On a benchmark test for biology and medicine questions, a standard GPT 4.1 model got about 8.5% correct. A specialized reasoning model did better, at almost 14%. But when they took that same standard GPT 4.1 and just equipped it with the CLIO framework, its accuracy shot up to over 22%.
I mean, just look at the sheer scale of that jump. Giving the model CLI didn't just give it a little nudge, we're talking about a 161% relative increase in accuracy. That's not just a small step forward, that's a genuine leap.
But maybe the most fascinating discovery wasn't even the final score. It was how the AI's own internal sense of uncertainty, its self-doubt really, turned out to be an incredibly powerful signal for whether it was on the right path or totally lost.
And you can see that discovery right here. It's brilliant. When CLIO was on the right track, its internal uncertainty would start high, but then steadily go down as it got closer to the answer. But when it was headed for a wrong answer, its uncertainty would spike and just fluctuate like crazy. It was almost like it was panicking, realizing it was going down a dead end.
So what does this all actually mean for us, in practice? Well, this research is about more than just getting better scores on a test. It gives us a real, practical framework for building trust and actually collaborating with these advanced AIs.
Those crazy spikes in uncertainty, they're not a bug, they're a feature.
They are, for all intents and purposes, the AI raising its hand and saying, hey, I am really not sure about this approach. Maybe a human expert should take a quick look. And that is the very foundation of a trustworthy AI.
So this gives us a kind of practical playbook for working with AI. We should demand to see the reasoning. We need to look for those confidence signals. We need to know when our own expertise is required to step in and steer. We can use the AI for that big, broad brainstorming, and then we guide its focus as it goes deep.
Ultimately, what CLIO really points to is a future that goes way beyond just using AI as a better tool. It's a path toward a true symbiosis, a real partnership between human and machine intelligence. And while this was proven out in a scientific context, you can see how this could be huge everywhere. I mean, any field that needs complex, subtle, recursive thinking, we're talking law, financial analysis, engineering, is totally ripe for this kind of steerable, self-aware AI partner.
And that really is the key takeaway here. The goal isn't just to build a smarter AI that gets more answers right. The real goal is to build a wiser partnership, where the incredible strengths of human intuition can work hand in hand with the massive computational power of AI.
Which leaves us with one final thought to chew on. Now that we can actually build an AI we can observe, steer, and trust, what's the one big critical problem you think we should tackle together?